In the capital of the German Third Reich, the results of a simple chemical experiment showed for the first time that the atom could be split, unleashing immense power. In the following months, as Europe braced itself for war, the Wehrmacht started a research program to develop nuclear weapons. The Germans were the first to start work on the atom bomb. Why wasn't Hitler the first to use it? Seven years later, Berlin was a ruin, and Germany's top nuclear scientists had been rounded up and interned in an English country house, Farm Hall. The fate of Hitler's bomb remained a mystery. These men alone knew what had really happened to German nuclear research during those turbulent war years. Among them was Otto Hahn. He was the chemist who carried out that simple laboratory experiment in 1938. He was soon to be awarded the Nobel Prize for discovering nuclear fission. Werner Heisenberg was the scientist in charge of the German nuclear project for much of the war. In 1932, he had received the Nobel Prize for his famous uncertainty principle. The aristocratic Carl Friedrich von Weizsäcker, one of a younger generation of German nuclear scientists who worked closely with Heisenberg. And their colleague, Erich Barger, an experimental physicist of distinction. From this inner circle of scientists, only von Weizsäcker and Barger are alive today. But their memories of that time are still vivid.
It was like a holiday inn. It was a fine time there. We had no chance to get a round football or something like that, so we get a rugby ball. It was very curiously for us, because nobody of us had any training in this with such a ball, and when we made fist ball, as we call it in Germany, from Putz with a strong fist, to bring the ball to that ring, it went in the other ring. But nevertheless, we made progress. And at the end, we could play relatively good.
Farm Hall was a nice house, not quite modern, and had a garden or had some lawns around it, and we were free to move along the lawn and to play with balls and so on, while we were informed, if anybody in the world learns where you are, 24 hours later you will be in another continent.
As the scientists may have suspected, their internment had a clandestine purpose. Allied intelligence were eavesdropping on their guests.
2 hearts.
Were they willing tools of the Nazis who had worked to give Hitler nuclear weapons and who might now sell their expertise to the Russians? Or were they simply scientists who'd been engaged in academic research of no military significance?
Fool's game. 4 hearts, then.
Some weeks earlier, Allied intelligence had tracked down the center of Nazi nuclear research. The German scientists had secretly moved their project from Berlin to Haigerloch in southern Germany. There, beneath the church, in a cliff, there was a disused beer cellar. In it, the Americans had found a nuclear reactor. An experiment on the brink of criticality. When these cubes of uranium were immersed in heavy water, a chain reaction would begin. A storm of neutrons would sweep through the reactor. Slowly, the uranium would be transformed into plutonium, the raw material of atomic bombs. Fear of what the Nazis would do with nuclear weapons had spurred the Allies into the biggest crash research program in history. While Heisenberg and his colleagues languished at Farm Hall, its result, a bomb called Little Boy, was aboard the Enola Gay on its way to Hiroshima. But had that fear been justified? 50 years on, it's a question historians are still arguing over. Among them, Mark Walker.
It's what kept the Manhattan Project going, this fear of Nazi nuclear weapons raining down on Europe or the United States. British politicians, American military men, American scientists, engineers, industrialists, no one could argue with the idea that if nuclear weapons are possible, and if the Germans are working on them, then we have to. A, we have to. B, we have to get them first. And this is a point that now is often forgotten, but the nuclear weapons really weren't intended for Japan. They were used against Japan, but they were intended for Berlin.
This is the BBC Home Service. Here is the news.
Scientists, British and American, have made the atomic bomb at last. The first one was dropped on a Japanese city this morning. It was designed for a detonation equal to 20,000 tons of high explosives.
Otto Hahn was the first of the Germans at Farm Hall to hear about Hiroshima. Allied intelligence hoped that the news would provoke a revealing discussion. But apart from a few brief extracts leaked by American sources, the British government has kept the recordings secret for nearly 50 years. A few days ago, the transcript was finally released.
It's an extremely complicated business. For 93, they must have a machine which will run for a very long time.
It's a bluff. Propaganda. The Americans are no better than the Nazis. They've invented some new kind of explosive and they've given it a fancy name.
Poor old Heisenberg. Makes you all look pretty foolish, doesn't it?
Was the word uranium used in connection with this so-called atomic bomb?
No.
Then it's got nothing to do with atoms.
They said one bomb was the equivalent of 20,000 tons of TNT. How do you explain that, Herr Professor?
I'm quite prepared to believe that it's a high explosive bomb. Well, I'm not prepared to believe that it's got anything to do with uranium. It's probably some chemical thing. Atomized hydrogen and oxygen, something like that.
But 20,000 tons? That's quite incredible.
Doesn't it strike you as odd that we, of all people, are surprised by this news? After all, we've been working on the problem for the last 5 years.
In any case, Heisenberg, if it's true, you're just a bunch of second-raters. You may as well pack up and go home.
The transcripts reveal the emotional reaction of a group of men who had been working hard on nuclear research and who simply couldn't understand how the Americans had got there first. But amidst their confusion and disbelief, there is frustratingly little hard evidence about why the German bomb project eventually failed. Were the German scientists really so morally and scientifically confused? Mark Walker believes there is another story to be told.
After the war, the Americans captured all the documents they could. They're available in microfilm. When the wall came down, I was able to get access to East German archives to which previously I would have been banned. And I found a great deal of material which shed light on these issues, in particular about Heisenberg's role during the war. I didn't want merely to examine what had happened during the war. I didn't want merely to examine the post-war controversy. I wanted to put the two together, and it's only when you put the two together that you can see what's really important about this story.
That story begins in the 1930s. It was a time when European politicians were struggling to appease Hitler and avert war. But in the world of science, a small international band of physicists were striving to understand the atomic nucleus. Every year, they met in Copenhagen to exchange ideas. Among them, the two great philosophers of quantum physics, Werner Heisenberg and his former teacher, the Danish Nobel laureate Niels Bohr. They were close friends, as von Weizsäcker remembers.
There was a really good personal relationship. They respected each other, they liked each other, and Bohr was the most important teacher Heisenberg ever had. Heisenberg once said, "I learned optimism from Sommerfeld, mathematics from the people in Göttingen, and physics from Bohr."
But it was a chemist, Otto Hahn, who made the crucial discovery that thrust physics into the center of world affairs. Dr. Alwyn Mackay.
I became a radiochemist in the 1930s when I went to work in Niels Bohr's institute in Copenhagen, and I was still working in this field at the time of Hahn's great discovery. And like, I suppose, everyone else who knew about it, it was simply astounding.
Hahn had been studying the behavior of nuclei of different elements of the periodic table by bombarding them with neutrons. When a nucleus absorbs a neutron, it becomes radioactive. It can then transform into a different element, either one or two places away in the periodic table. But uranium seemed to be an exception. When it absorbed a neutron, it appeared to jump 4 places down the periodic table to become radium. Hahn was puzzled by such a large change. In December 1938, he decided to check that radium really was being formed. The radium would be present in only tiny quantities, so Hahn, using the standard techniques of laboratory chemistry, added barium, a chemically similar element, to help him extract the radium. The next step was to add another substance that would react with both the barium and the radium to form a solid precipitate at the bottom of the test tube. This precipitate should have contained the barium he had added and the mysterious radium. But when he examined it, he found, to his astonishment, that it contained only barium. Hahn was forced to conclude that when uranium absorbed a neutron, it didn't change into radium at all, but into barium.
Now, this was quite revolutionary, and Hahn was so doubtful about the result that after he'd posted the letter describing it to the German scientific journal Naturwissenschaften, he said he wished he could get it back out of the letterbox.
What worried Hahn was that if uranium was turning into barium, that meant it wasn't jumping 4 places down the periodic table, it was jumping 36 places, and the nucleus halving in size. It soon became obvious to other scientists that there was a simple explanation. Fantastic as it seemed, collision with a neutron was splitting the uranium nucleus in 2. A number of important scientific papers followed in the next few months. Fission was a scientific sensation. But almost immediately, celebrations turned to alarm.
I should say 2 months later, in February 1939, I realized, and I think 200 people in the world realized at the same time, that now nuclear energy and nuclear weapons would be possible. But we did not do anything about it.
What made fission so dangerous was that as each uranium nucleus splits, it releases not only a huge amount of energy, but it also liberates more neutrons. These can collide with further nuclei, creating a hugely energetic chain reaction. Germany was arming for war. Military scientists were quick to realize that here was a potential new source of energy. And of course, they were always interested in powerful new weapons.
2 persons came to me after my lecture, which I didn't know them, and they came to me and told me, you are interested in nuclear physics. We are also. Would you be ready to come to us and make nuclear physics in our circle? And I asked them, from which place you are coming? And I said, they said, this is a military place. And then I said, oh, it is not so interesting for me. Please excuse me, I'm in an institute which I like very much. I will stay there. And so they went away.
But soon, the military would be able to command the services of German physicists.
In September 1939, on the 1st of September, the war with Poland began. And 6 days later, on the 6th of September, I got a call up to a military institution. You have to come on the 8th of September at Berlin, Hardenbergstraße 11, and I do all what is necessary for a normal soldier, my teeth brush and such things, and what is necessary normally. And I went to them, and then when I came to these people, I saw these 2 persons who spoke to me at Breslau just a year before. They had the possibility to take away anybody from his normal job. He has to come to us.
Barger had been summoned by Erich Schumann, a senior military scientist. The military were gathering together a powerful group of physicists to investigate fission. Heisenberg was drafted in to be the leading theoretician. Other scientists, like von Weizsäcker, were keen to be involved.
When the war started, I realized that these activities were now intense, and I approached them. I actively told that I should be glad to work in this. Of course, you may ask what was my idea in doing it, but in any case, these are the facts.
What was your idea in doing that?
Well, indeed, my own position, my own, let me say, mental position in the problem was perhaps the most complicated one, and therefore I first tell you what Heisenberg thought and also what Hahn thought. I think these 2 things are interesting and are simpler. Hahn, I visited Hahn, I think in September or October 39. I knew him very well. I had been working in his institute, and said, I propose that you participate in that work. And you should do it because this would save your institute from being dissolved or from being forced to do some quite other things which you don't like. And he said, I think you are right. I think I'm going to do it. But then he became very excited and said, but if by my work Hitler gets a bomb, I shall commit suicide. Hear the voice, how he said it. But we both agreed that this was not very probable. So much about Hahn. Now about Heisenberg. Heisenberg in that time, later on he changed his view just because things went differently, but Heisenberg in that time said, well, we can work on this matter, and we will need the result of the work after the war, especially what we call uranium machine, the reactor. But the war will not last very long. Hitler has a game of chess with 1 castle less than the other side. He will lose the war, and he will lose it within 1 year. So it's not dangerous. My own idea was more complicated. When I first understood that nuclear weapons might be possible, that was in February 39, I went to see a very good friend who was a philosopher, Georg Picht, and we debated this thing for a whole night. And our result was, if such a weapon is possible, there will be somebody who makes it. And if there's somebody who makes it, it will be used. And this means that mankind now comes into the position that either we will overcome the institution of war or we will destroy ourselves. This was our immediate reaction. And then I felt this is the most important thing, politically seen, which has happened in my life and which will happen in my life. And while perhaps I did not express it as clearly as I say it now, but my feeling was, it is true that Hitler will begin a war this year. But Hitler will not persist, but the bomb will be there forever. And my reaction was, since I am a physicist and I am able to work in this field, and since I am politically interested, I must in any case enter this field. I cannot keep outside.
Did you think about the politics, the morals?
I personally, not at all. I was like a soldier who had an order by the military people, and they said it is necessary to make isotope separation, and so I was thinking about these things.
Whatever their moral uncertainties, the scientists had embarked on nuclear research for the military. They now faced some formidable scientific problems. The outbreak of war had isolated Heisenberg and his colleagues from the international scientific community. But it's clear from the archives that they did have access to an important paper Heisenberg's friend Niels Bohr had published a few months earlier. In it, he argued that in natural uranium, only a small minority of nuclei would in fact take part in a chain reaction. The reason was that there are two forms of nucleus naturally present in uranium: the common isotope of atomic weight 238 and the rarer light isotope uranium-235. Bohr realized that only uranium-235 splits on being struck with a neutron. Uranium-238 simply absorbs it. Since over 98% of a lump of natural uranium was 238, any neutrons produced by fission would be quickly absorbed and the chain reaction stifled. Although a bomb could be made from pure uranium-235, separating it out seemed out of the question. For many scientists, including Bohr, this seemed to make an atom bomb impossible after all. But Heisenberg was soon able to see one step further than his mentor. Within a few weeks of the outbreak of war, he was writing a report to the army with good news to tell.
One morning I came to our institute in Leipzig, in the Linnéstraße 5, where our institute. I came by bicycle, and occasionally Heisenberg from the opposite direction came also with his bicycle, and we came together directly for the institute. And Heisenberg said to me, "Backe, come to me in my room." And suddenly I went there, and he told me, Heisenberg was very happy. I felt it. In the last night, he must have got new results.
Heisenberg realized that if you alternated layers of natural uranium with graphite or heavy water, this would slow down the neutrons produced by the fission of U-235. Slow neutrons would be less likely to be absorbed by the U-238, increasing their chance of hitting another U-235 nucleus and so causing a further fission. If the uranium machine, as Heisenberg dubbed this arrangement, was big enough, a controlled chain reaction could be maintained. But while this would produce energy, it would not be a bomb. However, 6 months later, in July 1940, von Weizsäcker made a further crucial discovery. As he explained to his military superiors, the uranium machine could be used to manufacture an entirely new nuclear explosive.
I realized that to make a bomb would be possible with what we now call plutonium directly, and that plutonium, or ecuranium as I then said, would be produced in reactors by the fact that the reactor works, and therefore that this was an important and interesting question. I wrote a paper about that, and I also, it was a secret paper, of course, and it was given to the Army Ordnance.
Like Hitler's Blitzkrieg, the German uranium project had made rapid progress. Heisenberg and his colleagues had displayed their brilliance. They had already mapped out to the Wehrmacht the route to the atomic bomb. Hitler seemed unstoppable, and as the months passed, Heisenberg's doubts about his research grew. He realized that he was probably in a nuclear arms race with Germany's enemies. The prospects were terrifying. In September 1941, Werner Heisenberg and Carl Friedrich von Weizsäcker left Germany. They traveled to occupy Denmark, to the Carlsberg Brewery in Copenhagen, a place covered in the symbol that the company had used as a trademark since the turn of the century. In the middle of the brewery was a garden, and in the garden was the Carlsberg Honor House, which had been bestowed upon Heisenberg's old friend Niels Bohr in recognition of the great scientist's work. Heisenberg and von Weizsäcker were to speak at a Nazi-sponsored scientific conference, but their trip had another secret purpose.
I already discussed it with Heisenberg, and we had the common idea that it would be good to prepare a talk between Heisenberg and Bohr on the question whether physicists all over the world might be able to agree not to make the bomb, or at least not to hurry it, during the war. And then we said there's one physicist in the world who has the moral and intellectual authority for achieving such a thing, and that is Bohr.
But in coming to Denmark as a guest of the German occupation authorities, Heisenberg had placed his old friend in a difficult position. Bohr felt obliged to boycott Heisenberg's talk.
At that time, we had already been occupied by Germany for more than a year, and there was generally no wish to have such cooperation with the Germans. And Heisenberg was coming here as a guest of an organization for cultural cooperation between Germany and Denmark. And this was considered, mildly said, a little tactless to come here as a guest of such an organization.
Bohr did, however, agree to meet Heisenberg privately at the Honor House. At this point, he had no idea that Heisenberg had been working for the military. Indeed, his own work on uranium-235 had convinced him that a nuclear bomb was not a practical possibility. Heisenberg, for his part, realized that in talking about his work at all, he was committing treason. What actually passed between the two men remains an enigma.
There are two different accounts, one from Heisenberg, one from Bohr. Heisenberg's account is as follows. I went to Bohr because I was troubled about nuclear weapons and my working on them. And I wanted, with the help of Bohr, to arrange an international strike among physicists so that no government would receive nuclear weapons. In effect, he went to Copenhagen to have Bohr help him stop all nuclear weapons. Bohr's account is very different. Bohr's account is that Heisenberg came and told him that A, he should cooperate with the German authorities in Copenhagen, B, that Germany was going to win the war, and C, that the Germans were making very fine progress on nuclear weapons. Now, you can reconcile these two very well if you take into account something else Heisenberg said about his visit with Bohr, and that is that Bohr didn't really pay attention. The Germans have a word for Beisprechen. They talk past each other, and it's clear from these two accounts that Heisenberg was saying one thing and Bohr was hearing another.
I had a talk with the German ambassador this morning.
Oh, yes?
Yes, about the future of the Institute, amongst other things. He tells me that you have no contact with him at all.
As I've already explained, the circumstances are such that cooperation, whatever form that might take, is quite out of the question. I'm afraid.
Yes, but those circumstances might change, mightn't they? I mean, the end of the war might not be so far away, a matter of months, perhaps.
Well, that is maybe.
It's your own welfare I'm concerned with, Niels. I mean, sooner or later, you're going to have to work with Germans. Might as well be sooner.
Oh, you think so?
Well, it would be better for you in the long run.
Werner, you simply do not understand my position.
I do assure you it would be in your own best interest to cultivate the German ambassador.
You must allow me to decide where my interests lie.
Of course, I have no wish to compromise you.
Perhaps we had better talk about something else.
Bohr's impression, I think, as far as he told me, was that he felt that Heisenberg was threatening. Maybe not threatening particularly Niels Bohr, but simply coming with some threats. Namely, Heisenberg was saying two things which would have been felt by anybody, I think, as threatening. Namely, he said that he was convinced that Germany would win the war and that they were able to make this terrible bomb.
In fact, what I really wanted to discuss with you this evening was a question that's been troubling me somewhat.
Really?
Concerning the military application of our work.
Military application?
I value your opinion on the moral issue, Niels. The question being, of course, whether it's right for us as scientists to be working on the uranium problem in times of war, when it's very possible that our work could lead to the most grave consequences in the technique of warfare.
You genuinely believe our work has military application, eh?
Well, of course. In theory, that is.
Wait, what are you saying exactly? What are you talking about? A bomb? An atomic bomb?
We've made some progress in that direction. It would take the most terrific technical effort, of course, but yes, it's a possibility.
Oh, my God.
A quarter of an hour after the end of the walk, Heisenberg saw me and said, "I'm afraid it was a complete failure." And then I said, "Why?" And he said, "Well, I started carefully, cautiously, and when Bohr realized that I was speaking about the possibility of making nuclear weapons, Bohr became so excited that he was not able to listen anymore, and so what I really had wanted to say was never uttered."
You see why I had to speak to you. Frankly, I'm at a loss.
Yes, I see.
The Americans are bound to be working on the same problem, so what choice do we have? The result could be absolutely catastrophic. The release of energy would be so immense, it'd be decisive. If only there was some alternative. You do see what I'm saying, don't you, Niels?
Oh, of course. It's inevitable. One must use all one's abilities and energies in the service of one's country in time of war. Naturally, physicists will be mobilized on both sides. I understand perfectly. Now, it's late. If you'll excuse me, I really must be getting back.
No, wait. Listen, Niels. That's not what I meant.
There is one other aspect of the Copenhagen meeting, even more puzzling than the misunderstanding between the two friends. At some point during the evening, it appears that Heisenberg gave Bohr a sketch.
Some have interpreted this as proof that Heisenberg was passing secrets to Bohr, proof that Heisenberg was resisting Hitler, wanted the German nuclear research to fail.
In 1943, Bohr escaped from occupied Europe and traveled to America, bearing the drawing which he had kept carefully. He took it to Robert Oppenheimer, the leading scientist of the US bomb project. One of the few people actually to see the sketch was another Nobel Prize winner, Hans Bethe.
Well, sometime in late 1943, Dr. Oppenheimer, who was the director of the Los Alamos laboratory, got a little drawing, and I'll draw that for you, which had come from Bohr, and supposedly had been given to Bohr by Heisenberg in the famous conversation in Copenhagen. It looked about like this. There was squarish box, and then on top there were some sticks. So we considered what this might be, and we very soon decided this must be the picture of a nuclear reactor. Every reactor needs control rods, and these looked very much like control rods. And so we said to each other, the Germans must be crazy. Do they want to throw a nuclear reactor at London? It will never work.
What Heisenberg passed to Bohr was already contained in published papers. In other words, Heisenberg wasn't giving Bohr secrets. A plausible explanation is that, as Heisenberg said, he was discussing their work with Bohr, so he drew him a diagram. But I wouldn't describe it any more importance.
Vast amounts of energy.
Yes.
Whatever Heisenberg intended to say, he left Bohr with the impression that the Germans were making rapid progress towards a bomb. But Heisenberg's moral reservations about his work were about to be overtaken by events. In the closing weeks of 1941, the Blitzkrieg ground to a halt at the gates of Moscow. The consequences of that defeat would have a dramatic effect on German nuclear research. Searching the archives of the bomb project, Mark Walker noticed an unusual flurry of documents produced in the aftermath of that defeat. He realized that here was the key to the fate of Hitler's bomb. The answer to the question, why didn't the Nazis get the atom bomb, lay not in the actions of the scientists, but in the demands of the men who really controlled the project, the military.
Because the Blitzkrieg came to a halt, and it was clear that the German economy needed to be well organized, reorganized, including armaments, the German army for the first time asked these scientists, will nuclear weapons influence the outcome of the war from either side? And for the first time, these scientists were put under pressure to deliver an answer.
To build a uranium machine to produce enough plutonium for a bomb meant committing billions of marks to convert laboratories into industrial plants. But could any country produce a bomb before the war ended? The answer to that depended on how long you believed the war would last.
In the meeting, Heisenberg told them that in principle it must be possible to make a self-sustaining chain reaction in a uranium machine. And then one of the generals who have been there, he asked him how long you need until you can produce, by your knowledge now, a weapon which could be decisive for war in which we are engaged. And Heisenberg said it's not possible at the moment. It can be done perhaps in 2 or 3 years about in this time. And so they said when it is not possible to make it within 3/4 of a year, then it is completely interesting for us.
If they were to turn the tide of war, the Wehrmacht believed they had to have wonder weapons within months, not 2 or 3 years. Rocket research offered the promise of quick results. In February 1942, the German army decided it was no longer interested in nuclear research. But in America, they were unaware of the German decision. It is one of the great ironies of the war that just as the Wehrmacht was rejecting atomic weapons, Fear of a Nazi bomb was pushing America into its own massive nuclear project.
It is striking to compare these two decisions because the scientific information was almost equivalent. What the German army had on its desk was the same as the American policymakers had on their desks. Now the difference is, in early 1942, most Germans assumed the war would only last a couple more years, win or lose. Germany did not have raw materials, had very few. Whereas in America, it was assumed that it would take many years, 4 or 5 years, to grind Germany down. So the difference was in perspective, perception. It was not in scientific work.
The German scientists had done their duty. They had worked diligently and reported honestly on the potential of nuclear fission. The decision of the army came as a relief to some and a frustration to others.
You have to distinguish between actions and intentions. After the war, these scientists emphasized that they had good intentions. We didn't want to make something for Hitler. But their actions, equivalent to actions done by American scientists, were in effect to work on the military applications of nuclear fission for the National Socialist government in order that Germany win World War II.
It was in a way not necessary to block it. And the question whether Heisenberg, for instance, would have agreed to make it if it had been easy is a question beyond reality. But I might think that if Heisenberg had come into this situation, he would have decided to act in a manner which, if possible, without endangering him, would make it impossible that the bomb would actually be made. So he did not want to die for this matter, but he didn't either want to do it.
It was decided that the further engagement in nuclear energy should be changed over from military people to the Ministry of Culture. And when we physicists heard about this, we spoke about a state funeral, first class, for our engagement. And we were frustrated by that.
In 1945, Allied intelligence received information that German nuclear research had transferred from Berlin to a secret location in southern Germany. In its last days, the Third Reich was alive with rumors that Hitler was about to drop the atomic bomb. And as the Americans stormed into Haigerloch, they still feared what Germany's scientists could produce. After the Wehrmacht abandoned nuclear research, it had continued under civilian control for 3 frustrating years, hampered by a shortage of uranium and heavy water. But now, Heisenberg and his colleagues felt they were onto something big.
Although the American project was, by this time, far in advance of the German scientists thought that, in fact, they were ahead. This is an ironic aspect of the story. And they thought that if they could only reach a relatively modest goal to achieve a self-sustaining chain reaction in a uranium machine, that would be a real achievement. And the fact that the war was being lost, the fact that Germany was being destroyed all around them, only made it more important that they succeed.
The cylinder was filled from the bottom and the surface of the water was rising. The neutrons which can be produced were measured from state to state while filling up. And the situation was so the number of neutrons was raising nearly linearly with the state of filling. And it was a chance that at the end, when the cylinder is filled fully, then perhaps we could have criticality. But in fact, it was not so. It made a curve and came to a horizontal intensity. This means we are still in a situation of subcriticality. But it was not so far away from criticality. We had about 75%.
All they needed was some more uranium. But supplies couldn't get through. Relieved Allied soldiers dismantled the uranium machine, but as its designers were carried into captivity, the German scientists remained convinced that they alone knew how to harness atomic power.
There was a great trauma at the end of the war. When they learned of Hiroshima, they simultaneously learned that their work was now somehow tainted. And also they learned that they were in second place.
At one time, 125,000 people were at work building the atomic power plants.
What I don't understand is how the Americans were able to separate 2 tons of uranium-235. It's incredible.
Well, one thing's for certain. They've clearly managed to cooperate on a tremendous scale. That would have been impossible in Germany. We were always too busy running each other down.
Well, I believe the reason we didn't do it was because we didn't want to do it. As a matter of principle. If we'd all really wanted Germany to win the war, we could have succeeded.
Nonsense. That's a quite absurd statement, Weizsäcker. Maybe true in your case, but not for the rest of us, I'm sure.
As you wish.
I don't believe it either. But I'm just thankful we didn't succeed.
We never had the sort of resources that other projects commanded. If we could have devoted the sort of effort that went into the V-rockets, then we might have got further.
Certainly a project on that scale would have achieved far more.
But we never even asked for such massive resources.
Well, in spring '42, who was going to ask the government to employ, say, 120,000 people just to get the thing going? Wouldn't have had the courage.
Thanks to Mark Walker's research and the release of the Farm Hall transcripts, the mystery of Hitler's bomb is at last being dispelled. But there is one final twist to this story, one character who seems strangely absent: the Führer himself.
The decision, should we invest the necessary money into nuclear fission research, stopped at an army bureaucrat, a physicist named Erich Schumann. And because it died there, it never got up to Hitler. Now, this same bureaucrat had to judge the German rocket research. And the same bureaucrat decided that that was promising. And because he said yes, that decision went all the way up the ladder. And there came a day when Werner von Braun and army officers interested in rockets had their chance to talk to Hitler. Because the German nuclear research project had in effect been frozen at a low level, as far as we know, Hitler hardly heard anything at all about it.
But once I approached Schumann, who was in charge of the whole thing in the military office, and said, would it not be good to tell some higher people in the government about this matter? And Schumann said, please don't do it. Because if Hitler, he said, der Führer, hears that nuclear weapons are possible, he will say half a year and then they must be there. And you know that this is not feasible, and for you and for me it would be a very bad position. Please keep away from such ideas.
The Germans did not try to make nuclear weapons, and they did not make them. The Americans tried to make nuclear weapons, and they succeeded. It does not logically follow that if the Germans had tried, they would have failed. Maybe, maybe not. However, recent work on the German rocket project has made this question more interesting. because historians now argue that the German government spent more money on rockets than the American government spent on the Manhattan Project. But this is one of those what-if questions which will remain unanswered.
Stalin certainly hasn't got it. Now, if the Americans and the British were good imperialists, they'd attack Russia with the thing tomorrow. But they won't. They'll use it as a political weapon instead. Of course, that's all very well and good, but the result will be a peace which lasts until the Russians have it. Then there's bound to be war.
Well, perhaps at last we'll be allowed to go home. What possible use can we be to them now?